All right, here's our final installment of making plots in ggplot. Here we're thinking about how could we have 3 or more variables in our plot, and these could be either categorical or quantitative, and how do we incorporate these differences here? The first way that we could think about it is taking our familiar scatter plot and taking that scatter plot and coloring the points based off of a categorical variable. So we see here that in our aesthetics, we are defining a third piece where we're mapping the color of the points to a specific variable in our data set, which is the species of the penguin. So when I were to run this code, I get a plot that looks like this, where each of the species has a different color, and these are all discrete colors because species is a categorical variable. If I instead would have colored by something like a quantitative variable, such as the body mass, which we'll make sure is grams, then I could see something like this where I see a color gradient where penguins who weighed more are getting lighter colors. So we see that overall these points over here are larger penguins, and penguins that are a little bit smaller body masses have these darker colors. So this is what coloring based off of a numerical variable would look like in a scatter plot. The other types of plots we have are plots that include categorical variables, so something like a ridge plot. In a ridge plot, what we have is we have our numerical variable on the x-axis. We have our categorical variable on our y-axis, so we get these sorts of stacks of these mountain ridges or these ridges. So what we can do is we can continue to add a third variable by changing the fill of each of those ridges based off of a third variable. So here we notice that we still have our x-axis as our numerical bill length. Our y-axis is our species, but here now we are filling those density plots based off of the sex of the penguin. So I'm going to go ahead and run this code and see what we appear. So we get each of our same ridges that we had before, but notice that in each of these ridge lines, we now have 3 different density plots. So we have a density plot for the penguins who are sexed as female, which are the pink ones, the ones that were sexed as male, which are the blue ones, and the penguins who were not sexed or unsexed, or that's missing, are the gray density plots. So this gives us a third variable. We'll notice that I have specified an alpha that's fairly low, so a 0.3 alpha, so that we're able to see between each of these different density plots. So this is where we can think about, we have now 2 categorical explanatory variables. We have species and we have sex, and we have 1 quantitative variable in our visualization, which is that bill length. So the other way, so we could add color into our visualizations for a way to add a third variable. The other way is we can add these things that we call facets. So facets essentially create different subplots based off of a variable that we're including. So here we could have that same scatter plot that we had before. So I'm going to highlight these 3 lines and run them. So this is that same scatter plot that we had before, except for now I've colored them based off of male and female sex. That doesn't really make a whole lot of sense, so let's go ahead and color them based off of species. So because species allowed for us to have a little bit more structure, so once we plot by species, we can see that these 3 different groups are separating themselves, so that seems like a pretty good fit. So what we could do is we could further facet, so we could further create a subplot based off of another variable, and maybe we want to be interested in sex. So if I run this, let's decipher what's going on. So what we call a facet is a different subplot. So we essentially get a different scatter plot for each of the different sexes in our data set. So we see a scatter plot for the female penguins, a scatter plot for the male penguins, and a scatter plot for the penguins that were unable to be sexed. However, in each of these scatter plots, we have that same idea where we're plotting the bill length versus the bill depth, and we're coloring based off of species. So for each of these faceted plots, we still are plotting the same exact plot for each of those 3 variables. The facet wrap allows for us to plot a third variable as a facet. So what we do is we specify this variable using the vars function, which it looks at your data set and looks for a variable that's named that name. So we look inside of the penguins data set and looks for a variable named sex. There is another way that you can do this using a facet grid function, but the facet grid function, what it does is we use this for creating a matrix of plots where we have a variable on the rows and a variable on the columns. So if we do sex and we were to do island, then we end up with a plot that looks like, so if we were to add in a second vars, so we could add in a second variable for the island that the penguin was on. So if we run this, then what we get is we should get a matrix of scatter plots. So we'll notice that like each of the data points included in these scatter plots continues to get smaller and smaller. So what we have here is we have our islands are on our columns, which is the second argument. Our sexes are on the rows, which is our first argument. So this one tells you the variable that's going to be on your rows. The second one tells you the variable that's on your columns. And now if we think about this, we have a total of many different variables in our plot. So we have bill length as our Y, we have bill depth as our X, we have species as our color, we have rows for our sexes of our penguins, and we have columns for the island. So we have 5 different variables included in one plot. So this is a pretty dynamic way for us to do this. We could also include facets with ridge plots, so something like those stacked ridges. So what I have here is instead of stacking the individual density plots like I had before, so if we go back to these plots back here, then we can see that these are all stacked on top of each other. If instead of stacking them on top of each other, I could, instead of coloring, I could facet instead. So what I could do is I essentially take that color piece where I don't have color in or fill in my aesthetics here anymore. Instead, what I've done is I'm only plotting my Y and my X variable. And then what I'm doing is I'm faceting based off of that third variable, that sex variable. So now I can get, here are all of the density plots for the female penguins, here are all the density plots for the male penguins, and here are all the density plots for the penguins who were not sexed. So this is also another way that you can choose. If you wanted to have 3 different variables in your plots, you could choose whether you want to use color to bring out that third variable or whether you want to use facets to bring out that third variable. So that's a choice that you get to make for yourself. And that concludes all of the plotting options that we have for plotting different types of variables and different numbers of variables in ggplot. I hope this helps for you. Bye.